Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 18, Least Common Multiple and Greatest Common Factor. Okay? Very often confused answering questions to least common multiple and giving the greatest common factor, or being asked what the GCF or greatest common factor is and giving the LCM or the least common multiple. Okay, the greatest common factor's division of two whole numbers is not both zero, is the greatest whole number that is a factor of each number. The greatest common factor of two whole numbers, A and B, is denoted by GCF, A parentheses, A comma B parentheses closed. So just keep in mind that if we are asked for the GCF, greatest common factor, factor means to divide. So if I want factors of 20, I am not going to get numbers bigger. I'm going to get numbers smaller. 1 times 20, 2 times 10, 4 times 5. 1, 2, 4, 5, 10, and 20 are factors of 20 because we're dividing. Least common multiple of two whole numbers is the smallest whole number greater than 0 that is a multiple of each number. The least common multiple of two whole numbers, A and B, is denoted by LCM, parentheses, A comma B, close parentheses. So let's just do 20 again. 20. So we're looking for the least common multiple. We're going to multiply. So we can't get a number less than the number that they gave us. So a multiple of 20 is 20 times 1 itself, 20 times 2, 20 times 3, 20 times 4, and so on, and so on, and so on. Multiples are greater than the given number because we're multiplying. Factors are less than the number that we're looking for because we're dividing. Keep that straight. So here's example 1. Find the greatest common factor, so the numbers are going to be less than because we're dividing. I always try to emphasize that. Don't confuse factor with multiple. Okay, so list these factor pairs in order to help ensure that no common factors are missed. Start with 1 multiplied by the number. So if I'm looking for greatest common factor, here's how we write it. Greatest common factor of 12 and 18, and we start with 1 and that number. Okay? We start with 1 and that number. And then we check to see if 2. So I take 12 divided by 2, and that is 6. 12 divided by 3 is 4. 12 divided by 4 is 3. Once you get to a point where you're repeating, see how these just crisscrossed? There's no need to continue. You're going to get 6 and 2, you're going to get 12 and 1. You're just doing a repetition. So once you repeat, you can stop. So I'll do that with this one as well. So 18 is even, so I know I can divide it by 2. And 18 divided by 2 is 9. 8 plus 1 is 9. Remember our rules from the last lesson. 8 plus 1 is 9, so it's divisible by 3. 18 divided by 3 is 6. 4 will not go into 18 evenly. 5 won't because it doesn't end in 5 or 0. And 6 will, but as you can see, we get that repeat switch. So we're done. We don't have to do that. So these are all the factors of 12, all the factors of 18, and we want to circle all factors that appear on both lists. So I have a 1, I have a 1, I have a 2, 2, 3, 3, 6, 6, 4, no 4, 9, no 9, 12, no 12, 18, no 18. These are the only ones we have in common. And then it says to place a triangle around the greatest of these. Well, 6 is greater than 3, 2, and 1. That is the greatest. So that is the greatest common factor of 12 and 18. Okay? That's greatest common factor. What factor do these both have in common, and which is the biggest common factor? Okay, now we're going to do an example for least common multiple. Multiple means the numbers are going to be greater than these. write the first 10 multiples of 12. So LCM 1218 means the least common multiple of these two numbers. So that's the notation for the question. So I'm going to do 10 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. Okay, first 10 multiples of 12, I'm sorry, write the first 10 multiples of 12. My apologies. Let me start over. 12 times 2 times 2, or 3 I mean, times 3. 12 times 4, 12 times 5, 12 times 6, 12 times 7. So 72 plus 12 is 84. You can also do it that way. Add 12, 96. Add 12 to 96, 108. Add 12 to 108 and get 120. And the way I can tell if I get to the 10th is 10 times 12 is just adding a 0 to the number we're looking for. So these are the first 10 multiples of 12. Now we're going to do the first 10 multiples of 18. Now what I explained in class was 18 is really close to 20. Okay? But 18 is 2 less than 20. 18 is 2 less than 20. So if I add 20 and subtract 2, I get 18. So it's kind of like a little mental math that we're going to do here. Okay? So 18, add 2 to the 1s, subtract 2 from the 8, or 18 times 2. Okay? Add 2 to the 3s, subtract 2 from the 6. And that gives us 18 more than what we started with. Okay? 54 plus 20 is 74, but I don't want 20, I want 18, so I subtract 2 from the 4. That makes sense. Add 2, subtract 2. 90 plus 18, 108. How do I know when I'm stopping? Put a 0 down here. I've got to keep going until I get to 180. So add 2 to 10, subtract 2 from 8. Add 2 to 12, subtract 2 from 6. Add 2 to 14, subtract 2 from 4. Add 2 to 16, subtract 2 from 2. And we are done. I'm in trouble with my commas here. So it's 180. We're done. 18 times 10 is 180. So these are the first 10 multiples of 18. When we're doing multiples, there's an infinitely many number. We can keep going forever and ever and ever. This just said to write the first 10. Now it says find the least common multiple. 12 is here, but it's not here. 18 is here, but it's not here. 24, no. 36, yes, there it is. 36 is the least common multiple. There are others, 108, 108, for instance, but that's not the least. 36 is the least common multiple. Okay, so it says circle the multiples appear that, okay, so I didn't follow the directions. So circle the multiples that appear more than once. Are there any others? No. And then it says draw a rectangle around the least. Okay. And yes, a square is a rectangle. Exercise Station 1, Factors in GCF. So the students each did one of these. They were in groups, and each one did one and presented it on the board. So I will go through and do greatest common factors of these. So 30. And I'm going to follow what they were doing. I was just walking around watching, and they were doing T-charts. And they said 30 is 1 times 30, 2 times 15, 3 times 10, 5 times 6. 50 is 1 times 50, 2 times 25, and 5 times 5. Okay? And then the greatest common factor. So since it's the greatest, why not start at the biggest number? 30's not here, 50's not here, 25, no, 15, no, 10, no. Okay, and then I see 5 times 5, so there's a 5. I see it 5 times 6, so 5 is the greatest common. 2's common, 1's common, but they're not the greatest. Okay? So we're just going to do all of these. So again, I'm going to do 30, and this time 45. The greatest common factor of 30 and 45. So the answer to this was 5. 30, as you can see, is already done. Just repeat. 1 times 30, 2 times 15, 3 times 10, 5 times 6. 45 is 1 times 45. 2 won't go because 5's not even. 3. 5 plus 4 is 9, so I know 3 will go into 9, it will go into 45. 3 goes into 4 once. 3 goes into 15 5 times. 3 times 15. 4 will not go into 45 evenly. 5 will because it ends in 5. And it's 9. 6. 7 times 6 is 42. No, not close enough. 7, obviously no, I just said it. 8 will not go into 45 evenly, so we are done. Now I look for the greatest common, and I see 15 and 15. So the greatest common factors of 30 and 45, 15. Now we're going to do the greatest common factor of 45 and 60. Okay. 45 has already been done, so I'll just come over here so I don't have to explain it again. 145, 3 times 15, 5 times 9. Factors of 60, 1 times 60. 2 times 30. 3 will go into 6, so 3 will go into 60 20 times. 4 goes into 6 once, remainder 20. 4 will go into 20 15, so it's 4 times 15. 4 will go into 25 times. Okay. Just doing mental math. 5 goes into 6 once, remainder, yes, 5 will go because it ends in 0, and it's 12. 6 will go in because 60 divided by 6 is 10. 7, no. 8, no. 9, no. And we're back to 10. So this was the list for 60. Circle the greatest. I forgot my 5 here. Circle the greatest common. Well, we can start at 45, but it's not here. 30 is not here. 15. So here's 15. Here is 15. Greatest common factor of 45 and 60 is 15. Okay? Next one is greatest common factor of 42 and 70. These are both new, so we need to do both of them. 42, 1 times 42. 2 is even, so it's divisible by 2. Half of 42 is 21. 4 plus 2 is 6, so it will divide by 3. It's 14. 4 won't go. 5 won't go because it doesn't end in 0 or 5. 6 times 7 is 42. And once we get that close, the next one's 7 times 6. It's a repeat, so we're done. 70 is 1 times 70. It's even, ends in 0, so it's divisible by 2. 35. 3 will not go into 7 plus 0, so 3 will not go into 70. 4 will go into 7 once, remainder 3. 4 will not go into 30. 5, because it ends in 0, yes. 5 goes into 7 once, remainder 2. 5 goes into 24 times. 6 will not go. 7 times 10. 8 will not go. 9 will not go. And we're done because we're back up to 10. So now we circle the greatest. 42, 35. 21, no. 14. Greatest common factor of 42 and 70 is 14. And finally, 96 and 144. Greatest common factor of these two. 96 is 1 times 96. 6 is even, so it's even. Divide by 2. 48. 9 plus 6 is 15. 15 divided by 3 is 5, so 3 will go. 3 goes into 9 3 times, 6 twice, 4 goes into 9 twice. 4 will work. Remainder 1, 16. 4 goes into 16 4 times. 5 won't go because it doesn't end in 5 or 0. 6 goes into 9 once. That'll work. 6 goes into 36 6 times. 7, no. 8, yes. 8 goes into 9 once. Remainder 1. 8 goes into 16 twice. 8 times 12. 9 and 6 is 15. 15 divided by 9, no. And we're up to 10. That'd be 9.6, no. 11, no. 12 times 8 is a repeat, so we're 144 times 1. 4 is even, so it's divisible by 2. See how we're using our rules from lesson 16? Okay. 4 plus 4 is 8 plus 1 is 9, so it will divide by 3. 3 goes into 14 4 times, remainder of 2. 8 times 3 is 24. 4 times 3 is 12. 4 will work. 4 times 3 is 12. Remainder 2. 4 will go into 24 6 times. 5 won't work because it doesn't end in 5 or 0. 6 goes into 14 twice. This will work. 6 goes into 14 twice, which is 12. Remainder 2. 2, 4. 6 times 4 is 24. So it's 24 times 6. 7 goes into 14 twice, but it won't go into 4. 8 goes into 14 once. 8, remainder 6. 8 will go into 64 8 times. 9, no. 10, no. 11, no. 12 times 12 is 144. That's a perfect square. 96, no. 48, yes. So the greatest common factor, 144 and 96 is 48. Okay? Alright, so this one says, next choose one of the problems that has not yet been solved. There are 18 girls and 24 boys who want to participate in a trivia challenge. So now we're going into word problems and using GCFs and LCMs in the real world scenario. If each team must have the same ratio of girls and boys, what is the greatest number of teams that can enter? Find how many boys and girls each team would have. Okay, so in order to solve this, we need to find the greatest common factor of 18 and 24. So, 18 is 1 times 18. It's even. 2 times 9. 3 times 6. 4, no. 5, no. 6 is a repeat, so we're done. 24 is 1 times 24. 2 times 12. 3 times 8. 4 times 6. Okay? So we're looking for the greatest common factor, which is 6. That tells us how many teams. Okay? If each team must have the same ratio of girls and boys, what is the greatest number of teams? What is the greatest number of teams that can enter? And we want everyone to participate. Okay? So we're going to have group teams of 6. 6 teams with so many boys. And 6 teams with a certain number of girls. Okay, well there's 24 boys, so all I have to do is say, what did I multiply 6 by? Okay, and 6 times 4 is 24, so there's going to be 4 boys per team. And then do the same with the girls. We need 6 teams of 8 girls, 18 girls and 6 teams are multiplied by 3. So there's our answer. We need 6 teams with 4 boys and 3 girls. Okay? So the ratios are equal. Okay, so let me just rephrase this. 6 teams with 4 boys and 3 girls. Okay? Every team's going to have 4 boys and 3 girls, and there's going to be 6 teams. Alright, ski club members are preparing identical welcome kits for new skiers. The ski club has 60 hand warmers, hand warmer packets, and 48 foot warmer packets. So we have 48 hand warmers of foot warmers and 60 hand warmers. Find the greatest number of identical kits that can be prepared using all the hand warmers and foot warmers. How many hand warmers and foot warmers would each welcome kit have? So that's a greatest common factor problem. 1 times 48. We could have 2 packs with 24 in it. 8 plus 4 is 12. 3 will go into 12, so 3 will go into 48. Okay. 4 will go into 4 once, and 8 twice. 5 won't go, because 8's not 0 or 5. 6 times 8 is 48, and then we're at 9, and then we're repeating, so that's it. 60 is 1 times itself, 2 times 30, 3 times 20, 4 goes into 6 once, 4 goes into 25, 5 goes into 6 once, and 10 twice, 6 times 10, 7, no, 8, no, 9, no, 10, repeat, done. Okay, so we found the GCF to be 12. Right, so that's how many kits we're going to have. We will have 12 kits with, and my answer to the problem is what we multiply 12 by. And 48 was foot warmers, so then there's 4 per 12. So 12 kits with 4 foot warmers. And 60 hand warmers. 5 times 12 is 60, so every kit's going to have 4 foot warmers and 5 hand warmers. Okay, so the GCF tells us how many kits, and what we multiply the GCF by tells us how many foot and hand warmers we need in each kit. Okay, there are 435 representatives, okay, and senators serving in the United States Congress. 435 representatives and 100 senators. How many identical groups with the same number of representatives and senators could be formed from all of Congress if we want the largest group possible? That's GCF. How many representatives and senators would be in each group? That's what we're going to multiply the GCF by. So I need to do GCF of 435. So we always start with 1 times itself. 5 is not even, so I can't divide by 2. So I'm on to 3. The rule for 3 is add the digits. 4 plus 3 is 7, plus 5 is 12. 12 divided by 3 works, so 3 will go into 435 once, and 145 is 0. Okay. For the rule for 4 is, will 4 go into the last 2? 4 does not go into 35, so no. 5, yes, because it ends in 5. 6, 7 times 6 is 42, 6 won't go into 15, so no. 7 times 6 is 42, 7 won't go into 15, so no. 8, will 8 go into 435, 5 times 8 is 40, 8 will not go into 35, no. 9, 4 plus 3 is 7, plus 5 is 12, 12 divided by 9, no, not an integer. 10, that'd be a decimal. 11, no. Now with these large numbers, it's always a good idea to check with a calculator, so I'm going to pause right here and get my calculator. Okay, so we're at 435 divided by 12. We only have rules up to 9, so once we get higher, we need to check. 435 divided by 13. Decimal, so no. I'm looking for integers when I divide. And how do I know when to stop doing this? And the number I'm dividing by meets the number that I'm getting. Well, here's an integer, so 15 times 29. So there's a factor. So if I come over here, it's 15 times 29. Okay, So I'm going to keep going now. 435 divided by 16. No. 435 divided by 17. Decimal. 18. Decimal. 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 Now notice what happened. I divided by 21 and I got a factor that was less, or actually a decimal factor that was less than what I divided by, so there's no need to continue. We've covered all the possibilities. So these are my possibilities for 435. Okay? I'm going to show you something really neat in lesson 19 that will eliminate this problem, by the way, but I wanted to show you what we have to do if we don't know that rule. So now I want to do factors of 100. 1 times 100, 2 times 50, 3 won't go, 4 times 25, 5 times 10, 6 no, 7 no, 8 no, 9 no, and now we're repeating. So look for the greatest. 87, 25, 29, 10, 5. The greatest common factor was 5. So we have 5 groups with how many representatives? What did I multiply 5 by? 87 representatives. And what did I multiply 5 by for senators? 10. And 10 senators. Okay? Okay, when I pause this, I notice I made a mistake. 5 times 10 is not 100. 5 times 20 is 100. So it's 20 senators. So fix that. This next question says, is the greatest common factor of a pair of numbers ever equal to one of the numbers? Explain with an example. And the answer is yes. So let's do GCF of 9 and 27. Okay, so we're going to do factors of 9 and factors of 27. One times 9, 3 times 3, and that is it. 1 times 27, 2 no, 3 times 9, and that's it. Okay. Greatest common factor is 9, which is equal to one of the numbers. So the answer is yes. And it's whenever the smaller number is a factor of the larger number. Okay, because we always multiply by 1 in itself. So if 9 is a factor of this one, then 9 is a factor of itself, so therefore 9. The greatest common factor is the factor of 27. Is the GCF of a pair of numbers ever greater than both numbers? No, because factors are always equal to or less than the numbers. And the reason is because we're dividing to get the factors. You can't divide by a number and get a greater number unless that number you're dividing by is a fraction, and we don't do fraction factors. Alright, the next example was doing LCMs, least common multiples. So I'm going to save some time here. Rather than doing the first 10 like we did in our example, I'm going to do one for each number and go until I find a pair. So least common multiple, or multiplying, we start with 9. 9 times 2 is 18. We start with 12. 12 times 2 is 24. Once I get greater than the other, I go back to the other. This is how I do it, so I find it without having to go beyond. 18 and 9 is 27. Now I'm greater than 24, so I come back to 12. 12, 24, 36. 36 is greater than 27, so I go back up to the 9. 9 times 4 is 36, and finally I found my pair. Okay, so I'm going to use that format for these. So 8 and 18, so I'm going to do 8, 16, 24. I'm greater than the other one now, so I'm going to start on that one. 18, 36. Go back up to here. 8 times 4 is 32. 8 times 5 is 40. I just surpassed this number, so I'm going to go back down here. 18, 36. Remember, add 2, subtract 2 for 18. Okay, go back up here. 48 plus 8 is 56. Pass this, so add 18 to 54. Add 2, 7, subtract 2, 2. 56 plus 8 is 64. 8 times 9 is 72. And there's my GCF. Okay? If that confuses you, then I would suggest doing the first 10 again. So let's do the first 10 on this one. 4, 8, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8, 32, 4 times 9, 4 times 10. So I did the first 10. 30, 60, 90, 120, 150, 180, 210, 240, 270, 300. I did the first 10. I got up to 40 here. I don't have a 30 here. And then I'm going to 60, so I have to continue this one. 44, 48, 52, 56, 60. Finally, we got 60. 60. Okay? 12, 24, 36, 48, 60. Okay, I see 30 here. So once you get the hang of this, you start seeing them. 30, 60, 90, and so on and so on and so on. And there is our least common multiple. Okay? Least common multiple of 20 and 50. 20, 40, 60, 80, 100, and 50 times 2 is 100. So we are done. Okay? Bear with me, I know this is a long video. Okay, next choose one of these problems that has not yet been solved, so on and so forth. We're just going to do all these. Hot dogs come in packs of 10. Hot dog buns come in packs of 8. If we want one hot dog for each bun for a picnic with none left over, what is the least amount of each we need to buy? How many packages of each items would we have to buy? So no, don't say, well, let's just buy one pack of each. We have 2 extra hot dogs, we'll throw them to the dog. Okay? We want to know, without waste, how many hot dogs and how many buns we need. So this is the least common multiple problem. So I want the LCM of 8 and 10. So I'm going to do multiples of 8. Until I get a multiple of 10. Remember, 10 is divisible by 0, so if we know our rules really well, it makes our process easier. So I'm stopping right there because I see a 0. 10, 20, 30, 40. Okay. It is very important that you learn the rules of this introduction to these problems, because you would have kept going out 10, and if you know the rules, you're saving time and steps. So there's my answer. Okay, I need 40 hot dogs and 40 buns, hot dog buns. Now it says if we want one hot dog for each left over, how many do we need to buy? So the answer is 40 hot dogs and 40 buns. Okay, and it says how many packages of each item would we have to buy? So now we have to divide. So 40 divided by our LCM 8 is 5 packs of hot dogs. Okay, and 40 divided by 10 in a package for buns would be 4 packs of buns. Okay, so there's an LCM question. B, starting at 6 a.m., a bus stops at my street corner every 15 minutes. Also starting at 6 a.m., a taxi cab comes by every 12 minutes. What is the next time both a bus and a taxi are at the corner at the same time? Okay, so we're starting at 6 a.m. 0600. Okay, and so we're doing LCM of these two values, which is 12 minutes and 15 minutes. So LCM of 12 is factors or multiples of 12, not factors, multiplying. 12, 24, 36, 48, 60. Okay? 15, 30, 45, 60. I stopped because I knew 15 would go into 60. Once you learn your multiplication really well, you'll see that, and you will stop. So, it's 60 minutes. So the next time both a bus and a taxi are at the corner at the same time will be 60 minutes after 6 a.m. and the answer is 7 o'clock, or 700 hours. All right. C, two gears in a machine are aligned by a mark drawn from the center of one gear to the center of the other. If the first gear has 24 teeth and the second gear has 40 teeth, how many revolutions of the first gear are needed until the mark lines up again? Okay, I wanted to bring in some pictures to explain to you what this question is asking. So here's a gear, and this has 24 teeth. So this is a tooth, and if you count around, 1, 2, 3, 4, all the way around to 24. So let's just say this is the tooth. No, let's not do that one. Let's make it over here. So let's say this is the tooth that we're going to mark with a marker. Okay, so if the first gear has 24 teeth and the second has 40, so I counted this one and it's got 40, how many revolutions of the first gear are needed until the marks line up again? So if I have a mark and I put a mark here, well, when I rotate these, this is going to do a full rotation every 24 teeth. But this is only going to be a little more than halfway around, so it's not going to line up the first time. So it's asking how many rotations will it take for the smaller gear for the teeth to line up again. So this is kind of a neat question. So here's one gear and here's the other gear. They mesh together. We start the motor or whatever spins it, and one rotation puts this back on this gear, but it will be over here at the 24th tooth. So here's the picture of what we're trying to do. Okay, so this is an LCM problem, and we're comparing 24 teeth to 40 teeth. So LCM of 24 is 24, 48, 24 times 3 is 96. Okay, 96 plus 20 is 120. Alright, and I've ended with a number in 0, so I'm assuming that 40, and there's no assumption, 40, multiples of 40 are going to end in 0, so let's see if that one's one of them. 40, 80, 40 times 3 is 120, so there is our LCM. Okay, so this 24-tooth gear is going to have to rotate 120 times before the two teeth line up again. Okay, D. Is the LCM of a pair of numbers ever equal to one of the numbers? And the answer is yes. So I'll give you an example. LCM of 5 and 20. 5, 10, 15, 20. 20, 40, well, least common multiple is 20. Is the LCM of a pair of numbers ever equal to one of the numbers? And the answer is yes. And that's if the smaller number is a multiple of the bigger. Okay? Is the LCM of a pair of numbers ever less than both numbers? No. Because to be a multiple, it has to equal a number or be greater. You cannot have a multiple less than the number 5, 10, 15, 20. I can't get a number less than 5. It's impossible. Multiples mean 5 times 1, 5 times 2, 5 times 3. We're not going to get a number less than 5 when we do that. Okay, and I think this is it. I'm not going to go over that. Okay, I'm not going to finish this. We're getting really far into time. I'm going to do it in a different video. So I will stop it here, and I'll do lesson 18 part B.